and now we're going to get into some polynomial inequalities. And again, we attack this very much like if it were x squared minus x minus 12 is equal to 0. So that's what we want to think about first. Okay? So the way that I would normally solve this, right, I have my choice of 4 different methods. I'm thinking factoring will work very nicely for me here. This factors as x minus 4 and x plus 3. So the first thing I want to do is find where my function is equal to 0. So at x equals 4 and x equals negative 3, I am going to get, right, these are places where my function is equal to 0. Now when I put these on my number line, just like with the absolute value, I come back here to this sign. This says greater than 0. So because there's no equal to 0, that means that 4 and negative 3 aren't actually solutions to my problem, but they are important numbers for me. So let's see, I want this, I'll make this 0 here. So I'm going to put circles around my numbers because I know that they're not included, but I know that they're important to me. So this particular inequality, saying that it's greater than or greater than 0, means that what I'm looking for are positive numbers. Okay, numbers that are bigger than 0 are all going to be positive. And so numbers can't go, if you think of a graph, right, my graph can't go from positive to negative without crossing over this line here that's 0. And so we're going to use that idea. So basically we're going to do just like we did with the absolute value inequalities, and we're going to check a test point in each interval. So let me use, for my test, I'm going to choose x equals negative 5 here. Okay. Now I always go back to this because this is a nice way, because I know that when I multiply two positive numbers I get a positive, and really all I want to know is the sign, right? Because if it's positive, then that's part of my solution. If it's negative, then it's not, because this is greater than. So greater than 0 means I'm looking for positive solutions. So I don't really care what the number is when I put it in. I only care about whether it's positive or negative. So let me try x equals, x is greater. I don't know what I'm talking about here for a second. So I'm going to test x equals 5, okay? And so what I'm going to do here is I'm going to put in negative 5 in here and just look at it. So I have negative 5 minus 4 times negative 5 plus 3. So this is going to be negative, right? It's going to be negative 9. And then this is times negative 2. And just so happens that a negative value times a negative value gives me a positive value. And so that means I have this piece right here that is in fact true. All right, so if I plug in 0, I'm going to plug in 0 into my factors, right? That's what I'm doing here. So I have 0 minus 4 times 0 plus 3. And this is going to give me negative 12, which is not positive, so this is not part of my solution up here. Now a number bigger than 4 gives me, let me just use x equals 5. I have 5 minus 4 times 5 plus 3. Again, it doesn't matter what that number actually is that this is negative 12, just that it's negative. So here I'm going to get 1 times 8, which is 8, but the only thing that really matters is that it's positive 8, right? That's the thing that matters. And so that means that my solution falls here as well. So I could write this solution as x is less than, or yeah, just strictly less than, because of this there's no equal to. X is less than negative 3 and x is greater than 4. So here's my solution. All right, I didn't plan very well here, so let me write this one that I have written up here instead. So let's see what happens if I just have the less than or equal to. So up here we solved, it was the same quadratic that was greater than 0. Here I have the same quadratic, but just this time less than or equal to 0. All right, so again, I'm going to go about solving it just like it was an equal sign, because these zeros are sometimes what we call critical numbers. They're important numbers. So we're going to factor it, and it doesn't factor any different than what we did before. Okay, I'm going to put my zeros on here. They are negative 3. There's my 0, so my 4 should be a little bit further away. This time, this symbol means I have an equal to sign. So actually the places where it is equal to 0 are part of my solution. So that means that now the negative 3 and the positive 4 are included. Now this one is less than 0, so this is where I'm looking for negative values. Now, the reality is that if these are where the positive values are, then probably it's this middle piece in here. But we'll just go through the process of just checking here. So if I check out x equals negative 4, I'm going to plug them in here, right? So negative 4 minus 4 is going to give me a negative number, so I'm just going to write a negative. And then negative 4 plus 3 gives me a negative number, which then a negative times a negative gives me a positive number. And I'm looking for negative numbers this time. So this is a positive, so this part is false, right? Or I often put like the sign of it up here, like this is positive because I know I'm looking for something negative. All right, so if I plug in x is 0, then I'm going to get a negative number because I get negative 4 there. I'm putting it back into my factors. I plug in 0 here and I'm going to get a positive number, positive 3 in fact. But all I care about is that the negative times the positive is going to give me a positive result, right? So this is the true space in here. So I know that this will be part of my solution. Then the last thing I can do is check for x is positive 5, and when I plug in 5 here, I get 5 minus 4, which is 1, so it's positive. And 5 plus 3 is 8, which is also positive. And positive times positive gives me, in fact, a positive answer. And so this is a false spot because I am looking for negative values because this is a less than. So my solution this time, when they're connected, I can write negative 3. I've got the x and I've got the 4. Right? This is the largest, and because of this equal, these also have an equal sign as well. All right, so let's look at that quadratic that I put in a, it's not a quadratic, but a polynomial. I put it in a bad spot there. This I'm going to give us already factored just because. Right, so we can use this idea even on, this isn't a quadratic because if I multiplied this all out, right, just this would give me a quadratic. And then if I multiply through one more time with an x, I'm actually going to get an x cubed as my highest power. So this is technically a cubic inequality. It is already factored, and so I thought we could try this out. It's exactly the same procedure as the quadratic. We first find the zeros. So we have x equals 0, x minus 2 equals 0, and x plus 3 equals 0. We're technically solving this. We're looking at where is this true first, okay? This gives me x is 0, x is 2, and x is negative 3. So I'm going to put these on my number line. So I'll put my 0 here first. I'll make that the 2. Negative 3 should be a little farther away. All right, so this is greater than or equal to 0. So let's think about this again. So that means that places where it is 0 are going to make it true. So that means that my 3 solutions that I found so far are part of my solution. And then greater than or equal to 0 means I'm looking for positive answers. So now my number line is actually broken into 1, 2, 3, 4 pieces instead of 3. So now I need 4 test numbers. So let me use x equals negative 4 to start. So I'm going to test something in this interval, something smaller than negative 3 that's not negative 3. All right, so I'm going to plug it right back in here into the factored version. So I'm going to have negative 4 times negative 4 minus 2, and then negative 4 plus 3. And I'm checking what's the sign of this. So this is going to be negative, right? That's negative 4. This is also going to be negative. I'll just leave off the 6. It's negative 6, but all I care about is it's minus. And then this one is also, negative 4 plus 3 is also negative. And when I multiply a negative times a negative times a negative, I get a negative number. So I'm going to put the minus up here. So that's the sign of my value. That is not what we're looking for, right? So that's not, this interval here is not part of my solution. So let me look at something between negative 3 and 0. Let me try x equals negative 1 is a nice one. All right, so if I plug that in, then I'll have negative 1 times negative 1 minus 2 times negative 1 plus 3. All right, so this will be negative, right? That's a negative piece. Negative 1 minus 2 is still negative. And now negative 1 plus 3 is actually positive. And so now I have these two negatives make a positive times this positive is positive. So in this interval, I end up with positive. So that means that this is in fact part of my solution. So I'm going to go ahead and color that in. All right, so now I need a number between 0 and 2. So 1 is the only integer between them, so let's try out x equals 1. I'll put this over here. All right, so I'm putting it back again into this piece right here. And so I have 1 times 1 minus 2 times 1 plus 3. So this is positive 1. This is negative, right? Negative 1. And then this is positive. And so I have a positive times a positive, which is positive, but then times this negative is negative. So it's negative in this interval. Okay? Not part of my solution because, again, I was looking for positive numbers. If this had been less than, then these would be part of my solutions and this one would not. All right, so now I just need a number bigger than 2. So last part, I'm going to pick a number in here. I'm just going to use 5. Why not? I could use x as 100 if I wanted to. All right, so now I'm going to put in 5, that's my x, times 5 minus 2, times 5 plus 3. This is positive, and this is positive. And when I multiply 3 positive numbers together, I'm going to get a positive value. And so here is my other piece of my solution. And so I write this then, I can write this as two inequalities, right? I can say that x is between 0 and it's equal to because of this symbol up here, right? I've got an equal to sign. So x can be between negative 3 and 0, or x is greater than or equal to 2. And those are my solutions. So the more zeros that I have, the more intervals that I have to test. All right, so if you have any questions about inequalities or if you want more examples, please refer to your P2 section.